Harsha?
Yeah.
Your stream is not coming, Nana.
Yeah, I had to switch laptops, so I just switched and I
Oh,
think it
okay.
should be.
Okay. You not started it. Okay. Yeah.
Okay.
Just show that.
Yeah.
So let me go to that line. There is some problem with the third grade. Let me go there and fix that.
Okay. Lines of symmetry. So you're going to learn understanding what symmetry means, finding lines of symmetry, drawing lines of symmetry, and identifying shapes that are symmetrical. Let's begin. Here are a few videos to get us started.
Today we will learn lines of symmetry. In the previous video, we learned that a figure which is in equal balanced ratio is called a symmetric figure. The given figures are symmetrical figures. To understand this better, let's now know what is the line of symmetry. Let's understand this with an activity. Take a piece of paper. Using scissors, cut the shape of the English alphabet A from it. Can you tell whether this figure is symmetric or not? Think for a while. Absolutely correct. If we keep the left half of it on the right half, then they are seen to overlap each other perfectly. This shows that they are reflections of each other. Therefore, we can say that the letter A is a symmetric letter. Just think, if we fold A in such a way that the top half of it comes down to the bottom half, then shall we say that A is symmetric? Think for a while. Absolutely correct. This does not make A appear symmetrical. On the basis of both the conditions, we can say that the symmetry of the figure is apparent only when it is bent along a particular line, like the vertical line passing from the middle of A here. Such lines which divide the figure into two halves such that both the halves cover each other completely if folded through that line are called lines of symmetry or reflection symmetry. It is also known as reflection line. By looking at the example of A, we can say that it is a figure with just one line of symmetry. But there are some figures in which more than one lines of symmetry are present. Look at this figure. Is there any line of symmetry present here? Think for a while. Correct. Here we can see two lines of symmetry, and apart from these, no other lines could be detected. Some figures have more than two lines of symmetry also. Like the symmetry in a square could be seen by folding it by these four lines. Hence, a square has four lines of symmetry. Similarly, Let's look at some other figures of geometry and find their number of lines of symmetry. Symmetry in a rectangle could be seen by folding it through these two lines. Hence, a rectangle has two lines of symmetry. If we look at a rhombus, then its symmetry could be seen by folding it through these two lines, and hence it has two lines of symmetry. Similarly, three lines of symmetry could be seen in an equilateral triangle. But if we look at a circle, any line passing through its center is a line of symmetry. And since there are infinite number of lines which can pass through the center, hence a circle has infinite lines of symmetry. Now take 5 different figures and find out the number of lines of symmetry in them. Today we learned lines of symmetry. In the next video, we will look at some interesting examples based on this.
In this lesson, we're going to identify the lines of symmetry in a 2D shape, and we're going to reflect an object in its axis of symmetry. We'll begin with question A. The pentagonal star has a line of symmetry at each vertex of the star, as you can see from the red lines of symmetry. So in total, there are 5 lines of symmetry in the pentagonal star. For question B, the equilateral triangle itself would have 3 lines of symmetry, but the arrow in the centre reduces that to 1 line. And for C, a circle would have an infinite lines of symmetry, but the rectangle in the centre gives it 2 lines of symmetry, vertical and horizontal. And for question D, again there is a horizontal and a vertical line of symmetry, which is 2 lines of symmetry. Now we're going to reflect an object in its axis of symmetry. And we'll do this by reflecting each vertex. So as you can see, as we reflect each vertex and join it to the previous one, every point is the same distance from the vertical mirror line or axis of symmetry. And we carry on like this to the end. For the second question, we're going to perform a vertical and a horizontal reflection. And again, each vertex is the same distance from the axes of symmetry. And now we're going to flip this horizontally, which is a horizontal reflection. And again, every vertex is the same distance from the vertical mirror line. And for question D, we're going to reflect the object through a diagonal mirror line, so every point passes through at 90 degrees. And again, the vertices are the same distance from the mirror line. And we carry on like this through both mirror lines, so you can see a clear pattern throughout. Thank you for watching. I hope you found it useful, and you can check out the full lesson in the link in the description.
Today we are going to look at symmetry, and under symmetry we are going to see two different shapes. First, we are going to look at the two-dimension shapes, and inside two-dimension shapes we shall look at a line of symmetry, then polygons. How many lines of symmetry to these regular polygons? So when you look at these regular polygons, there you go. The first shape is a triangle. So when you ask the triangle, when you look at the triangle there, you can see there are three because it is equilateral. There are three lines because it is equilateral. When you look at the second one, it's a square. And if you look at the square, it also has 4 lines, which we already saw. Now, the next one is a pentagon. The next one is a pentagon. So, when you look at the pentagon, it has to be all sides equal, a regular shape. So, if a pentagon is regular, then it will have 5 lines. So, when you look at the next one, it is a hexagon. When you look at that one, it is hexagon. So a hexagon will have got 6 lines. Hexagon will make 6 lines. And okay, when you look at the next one, the next shape here, when you look at the next shape, it's like 1, 2, 3, 4, it's the octagon. Octagon will have 8, but remember, all the 8 must be a regular shape so that it can be foldable. Okay, so when it's foldable, let's see the next. So that's a practical. You have to look at your name. You have to look at your name and check. When your names are in capital letters, do they have, each letter, does it have a line of symmetry? Okay, you can look to see if your name has symmetrical letters in it too. So you can check each letter and find out if you have got a line of symmetry on each part. So that's practical. For example, I can test maybe a name called Said. A name called Said. If you look at Said, Said has got 4 letters. It has got S, A, I, and D. When S has capital letter, it will not have a line of symmetry. When S has a capital letter, it will not have a line of symmetry. Capital letter with it. You draw things, letters have got a line of symmetry. So these are the letters which are symmetrical. They must have line of symmetry. A has 1 line, B has 1 line, C has 1 line, D 1 line, E 1 line. F does not have a line of symmetry. G does not have a line of symmetry. H has got 2 lines. I, as I told you, when I is considered thin, it has only 1 line of symmetry. J, no line. K, this K which has been drawn here does not have, but our normal K has 1 line of symmetry. Students, understand properly K. K, the way we draw K, it has 1 line of symmetry. The way they have drawn K here, yes, it does not have line of symmetry. But the normal way we draw K, it has a line of symmetry. L does not have a line. M has a line of symmetry. N does not have. O, we said it has got many lines of symmetry. P, no line of symmetry. Q, no line of symmetry. R, no line of symmetry. S, no line. T, it has one line of symmetry. U, no line of symmetry. U has one line of symmetry. V has one line of symmetry. W has one line of symmetry. X has two lines of symmetry. Y has one line of symmetry. And Z has no line of symmetry. So that is a presentation which shows lines of symmetry. That is a presentation which shows lines of symmetry. Now, after looking at lines of symmetry, we said we shall go and look at rotational symmetry. After looking at lines of symmetry, we shall go and look at rotational symmetry. Now, rotational symmetry is about rotating. Rotation symmetry is about rotating. So, in order for me to be able to rotate, let's take an example of a square. If I have a square there, see that? That's my square. If I have my square, I can rotate my square, see, using a tracing paper. I draw my square on top of my tracing paper, like that. I keep a starting point. Let's say I'll start from there north, and I find out where is my original center. Original center is there. So what I do next is I pinch at my center, and I have to rotate 360 degrees. But whenever the original shape regains its look, I get one order of rotation. So I start rotating. I rotate my tracing paper. I rotate, I rotate, I rotate, I rotate. That's one order of rotation. I move to the next. I keep rotating. I rotate. That's the second order of rotation there. Then I keep moving my tracing paper. I get the third order of rotation. And finally, I go back to the original. That's my fourth order of rotation. So practically, if I have got a square, it has got 4 order of rotation. So 4 order of rotation. In
Okay. So, if you've ever looked at your face in the mirror and you draw a line straight down the middle of both sides, you look almost the same. This is basically what symmetry is. So, say out loud symmetry. It means both sides match. What is symmetry? A shape is symmetrical if you can fold it, both sides match. You can fold it and both sides match exactly. The fold line is called the line of symmetry. So for example, a square. If we draw a line down the middle of a square, both sides are equal. So a square has vertical symmetry and horizontal symmetry. As well as this, it also has diagonal symmetry here and here. Just add that now. So there's one diagonal, and here's the other diagonal. So vertical, horizontal, and diagonal. So in total, we have 4 lines of symmetry. One going horizontal, one going vertical, and 2 going diagonal. So the next example is a rectangle. So a rectangle has one vertical line and one horizontal line. It does not have diagonal symmetry unless it is a square. So there's only 2 total lines here. You cannot cut through the rectangle diagonally. You can only do that when all 4 sides are equal and it's a square. So keep that in mind. The next example is a triangle. So an equilateral triangle has 1 line of symmetry. Some triangles have 0 lines. Important, not all triangles are symmetrical. This one in particular is a bit different, but most triangles, if this is stretched a bit, these lines disappear. But generally, we would say it has 1 line of symmetry. However, if it was truly equal on all 3 sides, then we would have 3 lines, since we could rotate the shape 3 times to get into its exact position. Now, the next one's a circle. So a circle has many lines of symmetry. It has almost really infinite lines of symmetry. You can draw a line straight through the center, and any line you draw straight through the center will be a line of symmetry. So basically, a circle has infinite lines of symmetry. Now, there are a few shapes with no lines of symmetry. So if you look at these shapes, there's no place where we can cut it into 2 and reflect it across itself to have the same shape overlapping itself. So we see that here. So now let's practice. Does this shape have symmetry? Wait 5 minutes. Okay. So does this shape have symmetry? So the first one, square. So we can cut it vertically, horizontally, and diagonally. Yes. 4. Now for 2. So 2 is also yes. And there's only 1, since we can only cut it vertically. And 3 is the same thing. Yes, only 1. Take another 5 minutes for this. Okay, so for number 1, you can see that it's a rectangle. So remember, it only has 1 vertical line of symmetry and 1 horizontal line of symmetry. So yes, 2 lines of symmetry. Now, this is basically a semicircle. So if we look at it very close, like if we look at it, there's 1 line of symmetry where we can fold it onto itself. So yes, 1. Now if we look at this shape, we can tell that the top is slightly smaller than the vertical distance. So there's no place to evenly cut this. Therefore, no. There's 0 lines of symmetry. Okay. So now, real life symmetry. So this is like symmetry all around you, like how it exists in the world. So it's things like butterflies. They're symmetrical. Books, they fold onto themselves, so they're symmetrical. And a leaf. So if we look at the first one, it has one line of horizontal symmetry. If we look at the book, it's in the shape of a rectangle. So we know that it has one vertical line of symmetry and one horizontal line of symmetry. And if we look at the butterfly and look closely, we can tell that it only has one vertical line of symmetry. So feel free to ask any questions, and we'll start some of the homework. So we'll leave the first 3. Okay, count the lines of symmetry. Write the number of lines of symmetry. So first up is a square. 1 vertical line of symmetry, 1 horizontal line of symmetry, and 2 diagonal lines of symmetry. So this would be 4. A rectangle. So this one would have 1 vertical line of symmetry and 1 horizontal line of symmetry. So this would be 2. An equilateral triangle. I'll give you time to think about all these. Okay. So an equilateral triangle, remember, it's equal on all sides. So we can rotate it again and again to get the same shape. So we have 3 lines of symmetry. 1 line is vertical and 2 are diagonal. So in total we have 3 lines. Now a circle. So a circle has infinite lines of symmetry. It's symmetrical everywhere, so any line passing through the center will always be symmetrical. So infinite. A heart shape. So a heart shape has one vertical line of symmetry. If you think about a heart shape, then there's only one place you could cut it so that it could fold onto itself. So one. The letter F. Zoom in. So this one should be pretty easy. There are 0, so let's just say 0. So we can do this one as well, and then we can end the class. So write yes if the shape has symmetry, write no if it does not. So a star. Does a star have symmetry? So a star does have symmetry, and if we look at it, there's one here, one here, one here, one here, and one here. So that would be 5. Now we already did the letter F, so we know no. And we also did a butterfly. So if we look at a butterfly, it has one vertical line of symmetry. And any uneven shapes, you can just automatically know that they're not symmetrical. And then now for a circle. Well, this should be pretty easy after going over it like 3 times. Yes. Infinite amounts of symmetry. A circle is symmetrical everywhere, so anywhere you cross a line through the center of the circle, it will always be symmetrical. So that's it for today. Have a good day.